In this video, I want to have a look at the quotient rule. So the quotient rule is used to differentiate when we've got a function that's the quotient of two smaller functions. So on your formula sheet, it looks like this. If we've got a function y that is u over v, where u and v are both functions of x, then dy dx is going to be v times du dx minus u times dv dx all over v squared. So it starts off similar to the product rule. We call one of our functions u and one of them v, differentiate them both, and then substitute them back into this formula. So if we have a look at our first example, we've got y equals 2x plus 7 over 5x minus 1. So our u is going to be that numerator, 2x plus 7, and v is going to be the denominator of 5x minus 1. So if we differentiate both of those with respect to x, du dx is going to give us 2, and dv dx would give us 5. So now we know those four things, we're going to substitute them into this formula. So dy dx is going to be equal to v times du dx, so this whole thing times 2, so I'm going to write that as 2 outside of 5x minus 1, minus u times dv dx, so this times that 5. I'm going to write that as 5 outside of 2x plus 7. And then all over v squared. So that's going to be our 5x minus 1 all squared. I'm just going to now expand out that top to simplify it down. So we're going to have 10x minus 2 minus 10x minus 35 all over that same 5x minus 1 squared. Now we've got 10x minus 10x, so they cancel each other out, and minus 2 minus 35 will give us minus 37 over 5x minus 1 squared. Our second example asks us to differentiate y equals 4x squared plus 3 over x cubed plus 4. So we start off the same way. U is our numerator, so that's 4x squared plus 3. And v is our denominator, so x cubed plus 4. We're going to differentiate both of those, and we'd end up with 8x for this one, and dv dx would give us 3x squared. So now we can put all that back into our formula. So dy dx is going to equal vu dash, so that's this times 8x. We're at 8x outside of x cubed plus 4 minus dv dx. So that's this times that 3x squared. So I'm going to write it the other way around, 3x squared outside of 4x squared plus 3. And all of that is over that v squared. So that whole x cubed plus 4 all squared. So now to make this a little bit nicer, I'm going to expand out. So we're going to end up with 8x to the power of 4 plus 32x minus 12x to the power of 4 minus 9x squared all over that same denominator of x cubed plus 4 squared. 4 is looking a bit weird. Now we've got this x to the power of 4 terms that we can simplify. So 8x to the power of 4 minus 12x to the power of 4 would give us minus 4x to the power of 4 minus 9x squared plus 32x. All over that same denominator again, so x cubed plus 4 squared. Now we could pull an x out of that numerator, or a minus x even out of that numerator if we wanted to, but it's not really going to make it a whole lot nicer, so I'm just going to leave it there. But that's two examples of the quotient rule.